Okay, the last case that we're going to look at today is if the center of the circle is outside of that inscribed angle. And in the one we talked about before, we used the angle addition postulate, that part plus part equals whole. So today, in this one, we're going to kind of do that in reverse. So our conjecture still again is that the measure of the inscribed angle is half of the measure of its intercepted arc. So for case 3, like we said, the the center of the circle is on the exterior of the angle. So here's your inscribed angle, BAD, and the center of the circle is on the exterior of it. So it says since point E is in the exterior of angle BAD, then angle BAD is equal to the measure of angle BAE minus the measure of angle DAE. So if we take this entire angle and we subtract this, we will get the measure of angle BAD. So that's the same thing then as x minus y. So the whole part, the whole thing minus a part will give you the other part of it. So for the measure of angle BAD is equal to the measure of the x minus y. And earlier back from case 1 and from case 2, we know that if this is x, if BAE is x, then we know that arc BE is 2x. So this would be 2x minus 2y. And then that would be half of that because it's the inscribed angle. So that's the same thing as the measure of arc BE minus the measure of arc DE, and taking half of that to get the angle. And measure of arc BE minus DE gives us the measure of arc BD. So this is still half of that intercepted arc. So those are 3 different cases depending on where that inscribed angle is in the circle. So then we have our inscribed angle theorem that says in a circle, the measure of the inscribed angle on a circle is half of the measure of its intercepted arc. I'll pause this so you can copy this in your notes. Okay, so the last thing is just identifying the hypothesis and the conclusion of the inscribed angle theorem. And so remember, if it was an if-then statement, the part that follows if is the hypothesis and the part that follows then is the conclusion. Now, this is not necessarily written in an if-then statement, but we can say if the measure of the if the inscribed angle is on the circle, then it is half the measure of the intercepted arc. So the hypothesis is that it's the inscribed angle on the circle, and then the conclusion, so this would be the hypothesis, and then the conclusion would be that it's half of, this would be the conclusion, the intercepted arc. Okay, so this is the part that you're given, and then this is the part that we were trying to prove, which we did in those 3 different cases. All right, real quick, looking at your homework. So for the first half of the homework, I would suggest kind of sketching this out, just drawing that triangle BAD. And when you have your triangle BAD, we know that if we want to create a circumscribed circle, you're going to have to find the perpendicular bisectors. And circumscribing the circle is where the circle goes around the figure and it intersects at all those points. So these would act as inscribed angles then. When you get down here, you might need to review your properties of special right triangles, the 30, 60, 90. Just to review the 30, 60, 90, you have your short leg, your long leg, and your hypotenuse. Your hypotenuse is twice as long as your short leg, and then your long leg is the short leg times the square root of 3. So that might help on that problem.